Hello everybody, Namaskar. Now we are in the 34th lecture of the course, and today we will discuss various aspects of ready to eat fruit products. Okay. So, we will discuss that what are these ready to eat fruit products and what is the technology of manufacture of common RTE fruit products which are available in the market, like fruit leather, resins and fruit chips. So, the ready to eat products, RTE fruit products, they refer to those products which are ready for direct consumption without any preparation. They are made in that form that one can use directly as a snack or other breakfast foods or such other in between meals, etc. These need no further preparation. So, a fast paced urban lifestyle, increasing dominance of nuclear family structure, raising disposable income and convenience of use have made the RTE foods very popular, and particularly RTE fruit products, because these fruits, they are considered as a hub of health promoting components, macronutrients, etc. So, the RTE fruit products are gaining more and more popularity among the consumers now. Okay. So, as I told you, these are the three common categories of fruit products are produced in the industries. They are leather, chips and dehydrated fruits like resins, dates, mango leather, fig, banana chips, pineapple chips and so on. So, all these products, that is removal of moisture by one or the other means to using a suitable drying techniques. So, heart of all these process is the drying and dehydration, and in other words you can say that the natural sugars which are present in the initial raw material, they are concentrated. When the moisture is removed, the natural sugars, they are concentrated and it gives the desired sensory and other characteristics, and also it improves the shelf life of the product. However, in their preparation, certain innovative novel technologies are needed, that is care is to be taken, so that, because in the drying we have already discussed in earlier what are the drying processes, etc. And as I told you, these products, fruits and vegetable products, they should contain good amount of micronutrient health promoting. So, the drying and dehydration technologies, mostly the innovative technologies or novel technologies which can preserve these bioactives to the larger extent, that should be encouraged. So, fruit leathers, they are dried seeds of fruit pulp which have a soft rubbery texture and a sweet taste. These are chewy, flavorful, naturally low in fat, high in fiber and carbohydrate, and these are also lightweight and easily stored and packed. So, in the market, that is like apple leather, guava leather, jackfruit leathers, kiwi fruit leathers, mango leather, pineapple leather, grape leather or pear leather, all this. So, any fleshy or pulpy fruit is suitable for making a leather. So, the pulp obtained from these fruit is used for making, and most common product even which is available in our villages also, the mango pulp is used for making the leather. So, here in the slide I have given you a process flow chart, general steps for manufacturing of fruit leathers, and this process is applicable to all, whether it is a mango leather or guava leather, pineapple leather, only depending upon the type of fruit that is used. Some treatment, process treatment, etc. may vary, otherwise the overall step may remain the same. So, what is done? That is, you take mature ripe fruits, obvious treatment of washing, peeling is done, then seed removal, like in the case of mango, etc., the seed kernels, etc., they are removed, and after that the pulp is extracted. So, you can say that is the fruit is pulp is obtained, and then this pulp is heated to around 75 to 80 degrees Celsius for a few minutes. After that it is strained, and after straining, so that some fibrous materials etc. they may go out, okay. And then it is added with the citric acid and sugars. After that it is boiled, then seated, that is it is spread in the form of a thin sheet in a container and in a tray etc., and then finally it is dried to around 55 to 60 degrees Celsius for about 15 to 16 hours, and the final moisture content of these leathers may be 14 to 15%, and finally it is packaged and stored. So this is the general process steps, okay. We will take up one by one, like the washing. Earlier in the earlier lectures we have discussed details of the methods of washing etc., but yes, here either soaking or spray washing or flotation washing is used, because these mostly the fleshy pulps are there. So the washing also should be taken with most care, so that the its outer skin etc. is not damaged during the washing. Otherwise this pulp, or there may be oozing, or there may be loss of the, so unnecessarily excessive pressures etc., spray jet etc., but it should be gentle washing, but thorough washing, and all this undesirable material, dirt etc. should be clean, then removed. Then after the washing, there is again now next step is the peeling. Depending upon the type of fruits used and its texture etc., appropriate peeling method, either manual peeling, chemical peeling, enzymatic peeling, mechanical peeling or thermal peeling, whatever is suitable for that particular fruit should be used. And again this also details how these peelings are done, we studied earlier, okay. So that method of choice may depend upon the type of fruit, like for peeling of apple may be a different, or peeling of the guava and other may be a different method. So accordingly use appropriate methods. So after the peeling, sometime peeling is pulping, like in the case of mango. After washing, it is put into the mango pulper, where the outer skin and seeds are removed by the pulper, and you get pulp. So as I told you, that's why I told you that depending upon what are the equipment that is being used, it will depend upon some of the, like mango, like even guava etc., you say that along with the pulping, that is smaller seed, this seed also has to be separated by appropriate staining or such other methods. So all these primary process will vary depending upon the type of the fruit. So the seed removal, seed are removed from the fruits after peeling. For the extraction of pulp, the seeds can be discarded, or they can be used for byproduct manufacture etc. For example, in the case of mango itself, this kernel is used, and then mango kernel powder is prepared, or these mango kernels, they are very good source of valuable fat, that kernel oils etc., good quality oil or fat they have. So these are used for making different byproducts. Then pulp extraction, again the pulp are extracted from fruits by either pressing or by maceration, that is standing for 1 hour, and decoction, that is boiling for 5 minutes. Again there is appropriate pulping method is used, and that will depend what is the type of pulper and all, it will depend upon the fruit being. Then after that pulp is heated to, as I told you, generally up to 80 degrees Celsius for removal of the excess moisture, and it increases the viscosity of the pulp and makes it suitable for molding and further operation. So after that it is strained, the heated pulps are cooled and pressed manually or mechanically and passed through stainless sieve etc., so that the fibrous particles etc., if there are any, or some of the finer seeds etc., in the case of guava and such other products, they are removed, okay. Then in this pulp, that is the sugar, citric acid and other preservatives are added. Sugars also improve the taste and they enhance and moldability of the pulp. Citric acid is added for improving the shelf life, whereas some other kind of preservatives can also be added depending upon the end application of the product. Then after that this material is boiled, pulp is boiled, and it is the very purpose of the boiling is the removal of water and making it a suitable for molding. That is basically it is, you can say, little bit concentration. You are concentrating. The water can be removed by direct boiling with continuous stirring, or the evaporator can be used for pulp boiling at industrial level. But here again during the boiling, at least appropriate novel methods if it is used, so that the boiling under vacuum concentrator etc. may be a good method. Then after the boiling, the next step is the seating of the pulp. The heated pulp are immediately spread on aluminum trays which is smeared with butter, and this seated pulp are then kept for standing for some time before they are put for proper setting, and once it is set, then it is put into the drying chamber. Okay. Then drying, wrapping, and finally storage of the pulp. This pulp in the tray, as you can see here in this tray, digital pulp, they are put in the dryer, and the drying may be done either by sun drying, shade drying, hot air drying etc. In fact, sun drying is the most commonly used method in the villages for making mango leather, and very common. It has been used since tradition. In fact, in that what they do sometimes, that is one layer is dried, and after that the another layer of the pulp is put, and then it is dried, and then third layer, fourth layer. So the multiple layers are found, and that gives even that layer after layer is added. Okay. So in general, the drying are done at in the controlled drying in order to get a better quality. Okay. Now even at general drying, even now even solar dryer, controlled solar dryers are also used. They are beneficial, or that is a air dryer or controlled air dryer where temperature can be controlled below 60 degrees Celsius, that is 55 to 60 degrees Celsius temperature, and it may take around 15 to 20 hours depending upon the initial moisture content, and final moisture content of the product may be 14 to 15% wet basis. So the dried pulp are cut into finally the pieces, wrapped in butter paper and packed in polyethylene bags, and the addition of up to 10% sugar to be extracted pulp are found to be ideal before drying the pulp to a moisture content of about 14 to 15%. Then let us see physicochemical properties of the fruit leathers. Okay. That is water activity, very important, because here we are removing the moisture, evaporation, concentration, and also you are adding some sugars etc., and which that is binds some of the. So normally these fruit leathers, they have intermediate water activity range, maybe around 0.6 to 2.7. The pH of the reported literature of the fruit leathers ranges from 3.2 to 5.8 depending upon the fruit which is used. Then the mechanical properties, fruit leather should have resistance to remain unbroken during processing, packaging, and handling. The leathers with high resistance is difficult to chew, while those with low toughness tend to stick to the teeth, and therefore moderate resistance should be there to have a, that is to deformation is desired, and accordingly these mechanical properties, resistance to deformation is very important, that is it has a good chewing phenomena, and that should be properly, drying process should be properly controlled. For proper control of drying process parameter, one can have a good or moderate resistance to deformation, proper characteristics. Then bioactives, obviously as I told you, fruit leathers are produced by, that is in order to improve or this, because in the sun drying, uncontrolled drying, excessive drying, these bioactives may get destroyed. So vacuum drying, freeze drying, microwave assisted hot air drying, okay, these are used in order to get a better retention of bioactives. Drying at high temperature occurs in shorter times and inactivates enzyme, which results in fruit leathers with high phenolic contents etc. So addition of sometimes starches and their derivatives decrease the oxidation of phenolic compounds during fruit leather production, and because the starches reduce oxygen permeation into the structure. So, that is an important aspect, that is that in order to retain bioactives, that is the drying process, innovative novel drying process should be used. Now, we will discuss the another very popular product in the market, that is the resins. A resin is basically a dried grape. These are produced, resins are produced in many regions of the world and may be eaten raw, or they are used in cooking or baking or brewing or for many other purposes. Okay. In India also produces significant amount of resins, and good quality resins are now available in the market. Resins contain phenolic compounds and antioxidants in huge quantity, which are essential for boosting the health of the people. They are considered very healthy material. In the presence of certain enzymes, these compounds cause the browning reactions. Earlier we discussed about enzymatic browning, etc. Okay. And so, there that is the pre-treatment and drying operations become very important. Okay. This pre-treatment and drying and their proper control play an important role in the final appearance of the resin. And in fact, by outward color development and glossy nature, that is just now the resins are different, that is appearance and glossy natures are available, and that is what is done by properly controlling the pre-treatment and the drying process parameters. So, it is necessary to select suitable pre-treatment and cost effective drying technology during the conversion of grapes into resins. So, in this slide, that is the what is the main steps for the preparation of resin. Basically, as you can see here, there are two, that is the grapes are taken a proper maturity, that is, you know, the viticulture is very important now in India. The grapes, then it is given to certain pre-treatment and then finally drying, that is. So, the other obvious operations like washing, cleaning, sorting, etc. The pre-treatment may be either chemical pre-treatment or physical pre-treatment. I will discuss little detail in the next slide, but that is a very important operation as far as the quality of the end product is concerned. And then after the pre-treatment, like the next becomes the drying again, the drying method, the conventional drying method or the novel drying method. So, in order to get a better quality, that is even innovative technologies or emerging novel technologies for pre-treatment as well as drying of grapes is important, and that we will consider. And then finally, the drying may be into 2 or 3 stages it is done, so that to get the material of proper characteristics, resins of proper characteristics, and they are ultimately packed and stored. So, let us discuss little bit. So, first is the pre-treatment of grapes, that is the chemical methods pre-treatment. They are in chemical treatment, they are dipped into specific chemical solutions at favorable temperatures for required time, and this is basically done to solubilize the waxy layer and quickly remove waxes from the grapes, that is the outer skins, and removal of wax results in a faster drying rate. And widely used chemical for pre-treatment of grapes include sodium carbonate, potassium carbonate, sodium hydroxide, or even sometime an oil emulsion like ethyl oleate or olive oils, etc. are used. Sodium hydroxide causes softening of grape skins, which results in easy permeability and thus increases the drying rate. Dipping of grapes in sodium hydroxide solution has also resulted in dull and pale resins. Ethyl oleate causes dissolution of the waxy component of grapes and improves the drying rate. It reduces browning and is considered better than the hot water treatment. Potassium carbonate, that is when the grapes are pre-treated with potassium carbonate, they are used, that is the drying process is improved. Potassium carbonate causes partial breakup of ester bonds present in the pectin of waxy layer, and thus it results in the faster removal of moisture during drying, and the drying operation is fast. Oil emulsion, that is the moisture diffusion rate as well as resin quality, can be enhanced using a possible combination of chemicals instead of a single chemical, like combination of various proportions of the chemical like 2% ethyl aleate emulsion and 0.5% sodium hydroxide, 4% potassium carbonate, or 1% olive oil, also called potash, or EO with K2CO3. All these various combinations can be made, and they have shown the improvement in the drying rate. Then sulfur compounds also, these sulfur like KMS and other forms, they not only increase the drying rate, but they also reduce the browning reactions by inhibiting the polyphenol oxidase enzyme. However, an excessive amount of sulfur dioxide may abruptly change the quality of the processed resins and can cause severe environmental problems. Sulfur dioxide sometimes is so sometimes this alternative to sulfur dioxide is required, or its consumption has been recently being avoided. There is a trend now. So the physical method, that is always even the chemical treatments can be avoided. So physical methods are also available, because the excessive amount of chemical sometimes have the residues and they can create the safety problems. So the physical treatment like abrasion, water blanching, ohmic heating, microwave heating, pulse electric field, ultrasound, etc., they can be used, which imply mechanical force, thermal energy, and even non-thermal process or mechanism technology, etc., which improve the drying rate as well as appearance and other characteristics of the product. So abrasion, that is shaker having walls covered with an abrasive coatings, are used for abrasion treatment. Abrasion causes 4 times increment of mass transfer compared to untreated samples. However, the treatment also resulted in darker resins compared to the chemically treated, and this was mainly due to the activation of polyphenol oxidase enzyme by opening up the micropores. So that is the enhanced rate of browning reactions are observed. The water blanching is the simple, easy and cost effective and easily adapted method. However, the extraction of in the water blanching, there may be extraction of colored pigments in blanching in the water. It reduces the bioactive components. So that is one has to use optimally, that is by proper methods of the pretreatment. And ohmic heating can be used as a novel pretreatment of grapes, in which that alternating current AC is passed through the grapes, causing heating due to resistance offered by the grapes, and formation of micro cracks on the grape surface by ohmic heating can enhance moisture diffusion rate. Microwave heating causes rapid evaporation of water and consequently partial puffing of the grapes. Thus, porosity of the grape is increased, which enhances the rate of drying, and nearly 2 times drying rate is increased after microwave treatment in compared to the untreated resins. Further, sensory characteristics also get retained due to inactivation of enzymes, etc. Pulse electric field treatment, when applied to fruit material, resulted in cell damage and softening of tissues, which causes increase in water movement from the grapes during the drying. The color of PEF treated samples is similar to that of the chemically treated samples or even untreated samples. The market acceptability of PEF treated resins is reported to be higher than that of chemically treated or untreated resins. Ultrasound treatment also can be induced, that is, it induces cavitation that affects the porous structure of the grapes. As a result, the drying rate of ultrasound treated grapes increased compared to untreated grapes, and also the dried resins, it has a good textural characteristics. So here now recent advances what has taken place in the technology of pre-treatment of grapes, because as I told you earlier, that is the quality of the final resin to a great extent depends upon the pre-treatment of the grape, and then finally of course the drying technology. So there are carbonic maceration pretreatment method, which utilizes carbon dioxide for loosening grape surface structure, or microwave hydrodiffusion and gravity method, which utilizes microwave energy for quick moisture removal where water excrete out of the grape and is collected. Then finally, third method is the high humidity hot air impingement blanching, where hot air with the high humidity at high velocity is applied on the surface of the grapes. Okay. The carbonic maceration pretreatment method, okay, it is here it reduced the drying time by 31% and retained the total phenolic content by 30% as compared to the untreated resins. Color retention of resins from the carbonic maceration pretreatment was also reported to be better than the chemical methods like ethylene, oleate solution, etc. So, what is done in this? That the grapes is placed in a closed tank and which is filled with the high concentration of carbon dioxide, then holding for an optimized time in that tank. Carbon dioxide gets soaked by the grapes and then intracellular fermentation begins, and which improves the water movement from the grapes. Then the microwave hydrodiffusion and gravity, that is commonly known as MHG, it uses electromagnetic waves, that is cause rapid heating of water inside the grapes. It resulted in quick evaporation of water from the grape cells and rapid retention of the moisture content. During the diffusion of water, some soluble constituents which are rich in nutrients like antioxidant, polyphenols, etc., secrete from the grape and are collected by gravity at the bottom of the equipment. Thus, the process is known as microwave hydrodiffusion and gravity. MHG process preserves high amount of anthocyanins, phenolic compounds and antioxidants in a very less processing time, that is only in approximately 10 minutes, and this makes the process economically viable for grape processing. Moreover, no residue is generated during the manufacture of resins and grape extracts. Thus, it promotes a circular chain production and it gives a very good quality resin. Then high humidity hot air impregnation blanching, HHAIB, that is a setup is a Fournier schematic representation. How it can be done? Basically, this technology is a combination of high humidity air blanching and impingement technology, which generally result in quick, uniform, minimum nutrient loss and energy efficient process. The HHAIB technology improved the drying rate by forming the microceramides on the surface of the grapes, which led to lesser resistance of water to diffuse from the center to peel of the grapes during drying. Then next is the drying technology. I told you that is the open sun drying. It may be used, that is it is advantageous of simplicity, feasibility, low cost, low temperature of drying. However, some of its common drawbacks are high drying time, weather dependency, possibility of mold growth and insect contamination, okay, unable to control the conditions, okay, attacks of bird, insects, etc. So, the shade drying, here the grape bunches are placed in a dark open place away from sun exposure in a proper airflow condition, and usually they are maintained by the surrounding environment. It uses the solar energy without direct sun rays on the grapes. Shade drying of grape usually resulted in a better color quality of resins than the sun drying, mainly because of the no direct effect on the sun rays on the grapes. Okay. Hot air drying is also known as the tray drying, which uses hot air as a medium to make temperature gradient between the grapes and the air with the simultaneous removal of moisture, and it is considered to be a good alternative compared to the sun drying of the grapes. But the novel methods of drying like microwave drying, this microwave drying produce resins with highest ascorbic acid content, highest rehydration ratio, good color properties, lower shrinkage than the hot air drying. Even pulse vacuum drying, in the earlier class when we were discussing dehydration of the, we discussed the detailed methodology of the pulse vacuum drying. So, this pulsating changes of the pressure resulted in a tunneling effect which regenerate the porous structure of fissures in the peel surface and enhances the drying, and it gives a good eating quality. And then microwave assisted air drying also, it accelerates the moisture droplets from the inside of the particle to outside, reduces the drying time, improves retention of color, and obviously enhances the drying rate. Infrared drying, that is when infrared waves falls into the highly moist food such as grapes, some part of the energy get absorbed, reflected, and only a fraction of the infrared spectrum passes into the material. So, first the surface of the grape is heated through the infrared waves, and then due to temperature difference, the heat is transferred to the interior of the grapes, and the intense heating decreases temperature gradient within a short interval of time, and it results in grape drying mainly by moisture migration in the vapor phase. Okay. Now, we will see third category of the popular important dried products, RTE fruit product, that is the fruit chips. They have become increasingly popular in the diet of the modern consumers because not only they can extend shelf life, but also provide appealing crispy mouthfeel, and they provide good nutrition. Different kinds of fruit chips available in the market are apple chips, carrot chips, jackfruit chips, pineapple chips, pear chips, or even the potato chips is very common products. Okay. So, the again methodology for all these chips preparation, almost the same sets of unit operations are there, that is depending upon the type of fruit or even the vegetables like carrots and potato etc., which are used. So, they have normal washing, peeling, de-seeding etc., then de-skinning, and then finally they are cut into the form of fine thin slices, okay, or in the appropriate, like in the case of jackfruit here, they are cut into 4/5 centimeter into 2 and 1.5 centimeter slices. So, the thickness of the slices also is important. So, thin appropriate thickness slices are cut, and then these slices they are before this they are blanched, and sometime in some cases, like in the case of apple chips preparation, or even in the case of this potato chips preparation, these there is even during peeling the enzymatic surface darkening may take place. So, the whole peeling operation itself, potato chips and apple chips etc., normally they are done in the brine solution. So, the while peeling, the peeling etc., is done in the 1% or 2% brine solution, so that the surface darkening can be avoided. So, maybe they are appropriately, again depending upon the type of fruit and vegetable, they are blanched, that is cleaning operations either during the peeling or even after peeling, they are appropriately blanched by either boiling in water or with maybe 0.1% KMS, that is in the case of jackfruit 1.1% KMS used at 90 degrees Celsius, and for 10 minutes it is dipped. Okay. In the potato chips, it is generally boiled for 2 to 3 to 4 minutes, so that gelatinization of the starch also takes place, and it is potato slices, thin slices are fully cooked. So, then after that the draining of the water, it is surface water is removed, it is kept for 10-15 minutes, and then finally it is put into the dryer. So, appropriate drying, there is normally tray drying 60 degrees Celsius for 1 hour or 70 degrees Celsius for, that is first it is done in the case of jackfruit, there is a for initial first 1 hour 60 degrees Celsius, so that a slight crust formation is taken on the surface, and then temperature is raised to 70 degree, and it continues around 6 hours 7 hours or so. So, this again drying condition here is depending upon the fruit appropriately, or even novel methods of drying like microwave drying, vacuum drying etc., this will give better quality products. So, after dry these materials are even many times that is these dried products are packaged and sent to the markets, and when at the time of consumption they are fried in the oil, salted and used. But Now these are when they are also made available in the form of ready to eat form, like this is after drying, they are fried in oil, salted, spiced and smeared with seasonings and then packaged appropriately with the appropriate packaging material, so that which is oxygen, water vapor impermeable, oxygen impermeable, etc., like those which we discussed earlier. The same thing holds true here as well. And then finally they are transported and stored at around ambient condition. But packaging is important aspect, because these are normally the chips they contain comparatively lower moisture content, maybe 3 to 4% moisture content. They are hygroscopic, so during if the packaging is not good, so they may absorb moisture, and their crispiness, for which these chips etc. are known, that may adversely affected, that may go. This is the banana chips. The same method it is discussed earlier. This is also the same process, like banana, green banana are taken, they are washed, then peeling, and finally slice. They are thin slices, and these slices are blanched into the hot water. After blanching, they are dried, frying, salting and curing, spice etc. seasonings are added, and then they are packaged. And these banana chips, they are deep fried snacks that are very popular now in many countries. Even India produces significant amount of banana chips, and it is exported even to many other countries. It contains good amount of magnesium, vitamin A, iron, phosphorus, potassium in small quantities, etc. So these were some of the ready to eat fruit products we discussed. So the important thing is that in order to make this ready to eat, they are given some sort of pre-treatment depending upon the type of the fruit, like we make it in the form of that pulp. These pulps are dried, and so that its shelf life is improved, or the materials are can be dried and converted into the form of resins or dried chips, etc. But in all the case, that is to make them stable by using one or the other methods, that is the moisture is removed, and before the removal of the moisture, they are appropriately converted. Obvious pre-treatments are given. So the important thing is that the pre-treatments, like the blanching, drying, all those things, that as far as possible, that improved method should be used, so that the end product quality is retained. That is for which these fruits and vegetables are known, their quality is retained in the product. And then finally, that appropriate packaging is very important, because all these, so drying process parameter, pre-treatment process parameter, and finally proper packaging, the packaging material characteristics, these becomes important. Otherwise, that is whole, these products are known for their crispy texture and good sensory characteristics, etc. If they are not properly packaged, then they may absorb moisture, and their whole purpose may get defeated. Their shelf life may be adversely affected. Their eating quality may be adversely affected. So these are the references used in this lecture. Okay. With this, I thank you very much for your patience hearing. Thank you.